If you're building a home lab, you will likely know this problem. Once you start adding more servers, deploying more applications, and experimenting with more gear, it's getting harder and harder to keep everything organized and connected. That's exactly why we're using VLANs, virtual local area networks, because they let you create multiple logical networks on one single physical switch without buying a whole rack of extra hardware, and together with a firewall, you can better segment your network into separate zones, like one for your home lab, one for your testing environment, or a DMZ, a demilitarized zone where your public-facing web servers are running, all protected from each other. That's exactly what I did a few years ago in my home lab, but until now I had one small problem. Although I already had different network zones, like my private LAN, my production server network, and a DMZ for public services, there was one part that was still not flexible enough, my Proxmox cluster, because that was just part of my production server network. And that meant all of my virtual machines and container workloads that I deployed on my Proxmox cluster also naturally ended up in the same network as well. And when I then, for example, want to put a home assistant deployment in a virtual machine on the cluster but connected to my private network, that was simply not possible by design. So I changed it. I made my Proxmox cluster VLAN-aware, and now my OPNsense firewall, the switch, and the virtualization layer carry all the same network design, and I can individually put a single virtual machine as part of any network zone that I want. So in this video, I'd like to show you how exactly you can build this as well. We'll cover what VLANs actually are, how the switch and the OPNsense firewall work together, and then finally, how to bring your Proxmox environment into this game so you get full control and full flexibility over your home lab network setup. By the way, before we jump into this tutorial, I quickly want to thank WhatsApp Gold for sponsoring this video. And this actually fits pretty well into this topic, because if you're running infrastructure, whether this is your home lab or maybe something bigger at work, you know that as soon as you start segmenting your network with VLANs, things can get complicated pretty fast. That's exactly where WhatsApp Gold comes in. It gives you a single place to monitor your entire network across devices, traffic, and segments. So instead of checking every switch, every firewall, every server and service separately, you can just see your infrastructure health, network performance, and traffic patterns together in one view. And that is really important, because monitoring is not only about getting an alert when something goes wrong. The useful part is understanding where the issue actually sits in. Is it just one device? Is it a group of devices? Maybe just one VLAN? Or is there an unusual behavior sitting inside the entire network? And WhatsApp Gold also includes a built-in network detection and response, so you're not only watching for outages, you can also spot unusual behavior earlier. And this gives you a much better visibility once your network becomes more complex. And if you want to try it out yourself, then check out the link in the description box down below to download the free trial and see how WhatsApp Gold fits in your network design. Alright guys, so now let's get started with VLANs. Before we jump into the tutorial part where I explain specifically how I changed my Proxmox cluster and made it VLAN aware, let's get everybody on the same page and let's quickly recap what VLANs actually are for. Again, as I said in the beginning, it stands for Virtual Local Area Network, and it basically allows you to split one single physical switch into multiple logical networks. For example, what I've done for my home lab, I've split my big physical switch into 3 virtual LANs. I technically have 1 or 2 more, but these are the most important ones. I have 1 virtual switch for my private network. You can see I've mostly assigned all the ports on the top row of the switch to that VLAN, where my MacBook, my Mac Studio is, my iPhone, and of course other home devices like TVs and things like that. And then I have a virtual switch for my production network. So this is basically for my container workloads, the virtual machines, Docker environments, basically everything that you see in my home lab. And the third one is for DMZ, so this stands for demilitarized zone, and this is a separate network zone where you usually put your public-facing services, because you typically want to isolate that part from your protected devices so that there is no natural lateral movement between your public-facing services and maybe your self-hosted password manager or something like that. Now, one thing is really important to understand. If you want to use VLANs in any network environment, you need a VLAN-compatible switch. switch. There are basically two types of switches in IT environments: managed and unmanaged switches. An unmanaged switch is basically a simple and dumb plug-and-play switch. There's no configurations, no VLANs, no control, but it's also super damn simple and mostly cheaper. However, a managed switch that mostly costs a little more, but this gives you a web interface or a CLI where you can configure certain settings, mostly also VLANs, and you can assign certain ports to VLANs and decide what ports are tagged and untagged. Now, this, for example, is my software switch, the CS11024FP. So I've already reviewed or shown this in previous videos. Here you can go to the configuration settings, and then I can create multiple VLANs. Now, it is important that one switch can assign each port on one or more of these VLANs. So you first basically create these VLANs by giving it a specific ID. VLAN IDs can go from 1 to 4094. VLAN 1, you can see, is grayed out, and this is a special one because this is often the default or native VLAN on many switches. So as a best practice, I would always avoid using VLAN ID 1 and start somewhere else. You can start at 2, 3, 4, and so on, but it is completely up to you what number you use. A switch that understands VLANs can send out traffic with a VLAN ID. These are called tagged. And network traffic without VLAN IDs. These are called untagged ports. And the switch automatically adds or removes this VLAN tag depending on the network port configuration. So when a packet leaves the device on that port then that belongs to this VLAN, the switch can add this small VLAN ID in front of the Ethernet frame. This is actually a 2 bytes ID that sits in the middle of the source and the data. And then the receiving device can understand, oh, this packet actually belongs to that specific VLAN. Now, when should you use what? So that, of course, depends on the actual device that is connected to that port. And untagged ports are mostly for normal devices like laptops, printers, computers, etc. They usually do not understand that VLAN tag by default. Of course, you can configure VLAN tags in operating systems if you want, but mostly you typically just connect a network cable to your computer and you don't configure a VLAN tag at all. So that way, when the switch sends out a packet that belongs to that network to that port, it removes the VLAN tag so a simple device can understand, oh, I just received a packet. Now, for other devices, like other switches, firewalls, Proxmox clusters, whatever, you might want to add this VLAN tag because then they can separate the network traffic from each other and they understand, oh, this packet actually belongs to VLAN 10. So here, for example, you can see that on my switch connection, I have added the first row as untagged ports of the private network, but the port 25 to 28 are considered tagged ports in multiple VLANs. So devices that are connected to these ports, like my Proxmox cluster or my OPNsense firewall here at the port 22, they now carry multiple VLANs. I've made them part of the private network with VLAN tag 10, VLAN 20, the production network, and the DMZ as well. And of course, I now had to configure these in the Proxmox cluster as well. It's actually not really difficult, but you have to change a few things. I've done this on all 3 Proxmox nodes, by the way. I went into the network configuration. You go into that physical interface or the VM bridge, whatever, and you enable this checkbox here. You make it VLAN-aware. So this port now understands VLANs. When I go to my server port 1, for example, I can go into the network device and add a VLAN tag. So this way, I easily put this production server on VLAN 20, which, if we return back to the switch, means the production network. So this way, I easily can put any virtual machine or any LXC container into a different VLAN and automatically and logically separate this out from the other networks. One thing is also important: if you want the Proxmox cluster itself to connect or to communicate with that VLAN, you also need a VLAN interface. That was needed for my setup because in my Proxmox cluster, it had an IP address on that production network. This is the primary IP address where I reached this device. And when you would change that network interface and make it VLAN aware, you also have to add a VLAN interface on the Proxmox cluster. So you have to go to network, create another Linux VLAN, and then give that the VLAN tag, for example, VLAN 20, and then just configure the IP address that you had configured before on the physical interface here on that VLAN interface, so that you, after changing or applying the configuration changes, you can still reach your device. Otherwise, you might log out yourself. This is what actually happened once to me, and I needed to connect a mouse and a monitor and a keyboard and go into the shell and repair this. Here, by the way, you can add the VLAN raw device, so that is the name of the physical interface where this VLAN interface should be connected to. So in my case, this is VMBridge 1. And this is the way how I've configured all of these different VLANs. So you can see this in VLAN 10. The Proxmox cluster has its own IP address in my private network. So it is actually reachable by any of the private devices at that IP address and any of the prod devices at this IP address. I, by the way, also used that to connect the HA link on the free Proxmox nodes. I know it is not recommended by Proxmox. You should not do this. But honestly, guys, I don't care. I want my Homelab to be simple and efficient, so I did not want to buy a separate physical switch. So what I've done is I basically created another VLAN that is called VLAN HA91 and sent out traffic to this VLAN 91 as tagged network traffic on port 25 to 27. And then what I've also done in the Proxmox cluster, so on all 3 Proxmox nodes, it was really important, add also a VLAN 91 interface with that IP address, 10.91.04.16. And on the other Proxmox nodes, of course, this actually looks the same. So this, for example, has the 10.9.1.5, and the Proxmox nodes 3, you might already guess it, has the .6 at the end. And then in the Proxmox HA settings, when I can remember where they are, I think it's at data center cluster. Here you can see these are the IP addresses that I use for the link. So the whole communication to the Proxmox cluster and all the different VLANs, the HA communication, the Ceph link, everything goes through these 3 ports. Let me demonstrate how that works. So here's a Windows test machine that has 2 network interfaces that is connected to VLAN 10. So this is my private network, even though it's running on my prod network Proxmox cluster. And I also have a secondary interface that is in the VLAN 30. So that's the DMZ VLAN, just for experimenting. And just to give you an idea of what that looks like, if I connect to RDP via this machine, here you can also see those 2 interfaces. It gets an IP address from the firewall that is 10.10.1.5, or I have manually configured this. I see that usually the DHCP gives IP addresses in 10.10.0. 1 to 254. This is the primary DNS. The standard gateway is also the firewall within that VLAN 10, the LAN network IP subnet. And for example, if I want to connect to a machine like the 10.20.02, that does not work with a ping request, because in my firewall rules, I do not allow anything else than DNS or 443. But if I do, for example, an NS lookup like ns.home.ccrave.de at the 10.22 IP address, you can see that actually works, but I could not open an SSH connection to the same device, for example. Yeah, that is simply not allowed. However, what I can now easily do, if I return back to my Proxmox network and I change the secondary interface that is currently in the DMZ zone to the VLAN 20, so that the virtual machine actually becomes part of both VLANs, the LAN and the prod network, then I can easily return to the Windows machine. You can see that the network port gets an IP address from my DHCP server that is 10.20.10.35, so that it's logically connected to my prod network. And now, because it's part of this network, it is able to ping any of the machines like the server.2, the server.3, and I could now also open an SSH connection. Of course, I still need to authenticate, but this device is now part of that network, and I can easily change that back again. You can see that this immediately stops working because the firewall receives that incoming request from the virtual Windows machine on a different network that is not allowed via the firewall rule. All right, so let's take a look at the OPNsense firewall. So you might have seen this before as well, but I think it's an important part of this story because without proper firewall rules, your VLANs are basically just separated networks. Nothing is actually protecting the devices from VLAN 10 to VLAN 20. Many people think that VLAN alone make their setup secure, but they don't. They're basically just segment networks. Only when you add in firewall rules, you do really control what device can talk to another, because otherwise any machine from VLAN 10 can just send out a network packet that belongs to a device in VLAN 20. It will send the network packet to its default gateway. If it's just your home router that is connected to all these separate networks, the home router will just forward the packet without any other controlling instance. So that's why you should always use a firewall and not a router. And you can, of course, very granularly define that for a single device, for a whole network, and add incoming and outgoing rules and all of that stuff. Now, let me show you how I have configured that on my OPNsense firewall. So first of all, you have to go devices and then VLAN. So here you can add all of your VLANs attached to one physical interface, similar like you do it on the switch, just in a slightly different menu, of course. So here, just pick any of the physical interfaces, maybe the Realtek interface 1. Give it a device name, like temporary, and then a VLAN tag, for example, 67. I'm sorry, guys, but my son is currently getting on my nerves with 67 all the time. It's just in my head. It's let's not talk about this. Now, what is also important, if you configure a firewall that should enforce firewall rules on these networks, it should have an IP address in all of these networks, of course, and they should be different. Otherwise, the switch might just route this internally and it never gets to the firewall. Only when it's logically separated with a different subnet mask, the device will send this out to its standard gateway, the firewall. You have your interfaces once you've created them here, and then you go into LAN, for example, and give this a static IPv4 address. In my case, the 10.10.01 network with a subnet mask of 16. So that means that 10.10 is actually the network part, and anything after that is actually the host part. And on the prod network, for example, this starts with 10.20.01. That's, by the way, the reason why I've chosen VLAN 20 for this, so I can easily remember that IP part. And then you can go into firewall rules. By the way, I've not migrated yet to the new firewall rule set in OPNsense. Maybe I'll do a separate video on this as well. But here in the firewall rules, for example, you can see that there are firewall rules that usually prevent any unknown device from the LAN network to connect to any destination, such as the trunk network, the management network. I only allow traffic from the LAN devices on specific ports on the server port 1. So this has that IP address, and I only allow DNS lookups and HTTPS, so that no device from the private network is allowed to open or establish an unsecured HTTP connection or an SSH connection or anything else to this production server. This is where my services are hosted that are actually known to the private network. And then I, of course, have also created separate firewall rules for my devices like MacBook Studio, MacBook Air, MacBook Pro. You probably know, guys, I'm an Apple fanboy, yeah? So I'm not gonna lie to you, of course. But yeah, these devices where I usually work with, they, of course, need to connect to all networks, yeah? Because otherwise I would log out myself from my Homelab. So this is basically how to use VLANs in your Homelab. Of course, I know this is a topic that is sometimes a bit complicated and you have to think through it. And I know it's probably not for everyone, but if you want to replicate a setup that is quite common in professional and enterprise environments, this is how you usually do it, just at a larger scale in that enterprise companies, of course, but you can still practice with the same technology about network segmentation and protection using firewalls in your own Homelab. It's absolutely amazing. You just need a VLAN compatible switch, and maybe 1 or 2 computers where you can test it, but that's actually all you need to play around with this. And as I said, now that my Proxmox cluster is VLAN aware, I gained a lot more flexibility to test and experiment with new workloads like virtual machines or containers in one specific network. I absolutely love this. By the way, we have not covered containers yet, so how to actually add a container to one specific VLAN. I might do another session about Docker VLANs at some point. So don't forget to give this video a thumbs up if you'd like to see that, and don't forget to subscribe to the channel if you want to see more tutorials. And as always, a big thanks goes out to all of my supporters and members of my channel. You guys are really amazing. And to everyone else, thank you so much for watching. Of course, I'm gonna catch you in the next video. Take care. Bye bye.